Alright, here's our last little set of notes that we have for Introduction to Probability. And so in the last set we looked at determining the total number of possible outcomes that we have for some experiment. And so once we know that, we can start to consider the number of times that the outcome of interest that we want to look at will actually occur. And so here we're going to be doing two example problems to kind of show you how to do that for something simple like coin flips. Now for things that are more complicated that have a lot of possible outcomes, the method I'm going to be showing you here to determine how many outcomes of interest will actually occur won't really be feasible, and you'll see why. But we will cover that problem when we get there. No need to worry. Alright, so first we are going to find the probability of flipping two coins and having both of them land on heads. And so, just like in our previous little examples, we need to first determine the total number of possible outcomes. And so here, n, total number of possible outcomes. Our first coin flip has two possible outcomes. Our second coin flip has two possible outcomes. And so here, n equals 4. So we have 4 total possible outcomes. Once we know that, we can start to, like I said, consider how many possible outcomes do we have with the thing we're looking for, which in this case is having both our coins land on head. So here, I'm going to set up a little chart. And so I'm going to do 1 for flip 1 and 2 for flip 2. And so since I have 4 total possible outcomes, I'm going to set up this chart here with 2 columns. I got 2 coins, and there's going to be 4 rows in it. And I'm going to split both these rows up basically evenly between heads and tails. And so the first one here, I'm going to do heads, heads, tails, tails. And then for flip 2, same thing, but just different pattern. So heads, tails, heads, tails. And so that is all our possible outcomes. So if we look at it, we got 1, 2, 3, 4, just like we should, right? And so now we can look at how many of these outcomes have both the coins landing on heads. So if we look at our first outcome, we got heads, heads. Well, that's looking good. We'll put a dot there. Run number 2, we got heads, tails, which is only 1 head, so not enough. Third one, we got tails, heads, so only 1 heads again, not enough. And then fourth one, we got tails, tails. We got no heads there, so that's not what we want. And so if we look at these, out of the 4 possible outcomes, we have one of them that is landing with heads, heads. And so we have the probability of getting both the coins to land on heads is equal to 1 divided by 4, because there's 1 possible outcome out of the 4 total. And so our probability of that happening is 1/4, or 25%, or 0.25, or however you want to write it, doesn't matter. But there you go. Easy peasy. Alright, so there's example number 1. Example number 2 is similar, another coin flip question. And so here we are going to be finding the probability of flipping 3 coins and having 2 of them land on heads and 1 of them land on tails. And so first we're going to determine the total number of possible outcomes, just like we did previously. Sorry, let me get my paper set up here. There we go. Alright, so we got n is equal to, so our first coin has 2 outcomes, our second coin has 2 outcomes, and our third coin has 2 outcomes. So we have 2 times 2 times 2, which is equal to 8. So we have 8 possible outcomes. Once we know that, we are going to set up a chart just like we did previously, but this time we're going to have three columns because we have 3 coins, and each column is going to have 8 rows because we have 8 possible outcomes. So let's go ahead here, and I got 1, 2, 3. Alright, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8. And again, you'll notice that I did 4 heads and 4 tails, so splitting it up 50-50, even just like I did before, just now with 8 rows. And so here, I'm going to go heads, heads, tails, tails, heads, heads, tails, tails. Again, splitting it up even, just kind of going with a different pattern. And then on the third one, I'll do the heads, tails, heads, tails, heads, tails. So here we go. We got heads, tails, heads, tails, heads, tails, heads, tails. All right. So now that we have our chart set up here, we can go through and look at how many possible events that we want. And so really we are looking for 2 heads and 1 tail. So that's what we're looking for. And so if we look at our chart here, we can go down just row by row. And so here, first try, we got heads, 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 which does have the 2 heads, but we don't have a tail. Here we got heads, heads, tail. Boom, perfect. We'll put a dot on it. Here we got heads, tail, heads. Still has 2 heads and 1 tail, so good to go. Here we got heads, tails, tails. 2 tails, only 1 head, so not what we want. Here we got tails, heads, heads. 2 heads and a tail. Boom, put a dot on it. Here we got tails, heads, tails, which 2 tails and a head. Not what we want. Here we got tails, tails, head. Not quite. Tails, tails, tail. Not what we want either. No head. So of the 8 possible outcomes, 3 of them have what we want. So here we got the probability of 2 heads and a tail is equal to 3 divided by 8, because 3 have the event that we want, and there are 8 possible events or 8 possible outcomes total. So 3/8, or if you wanted to do that as a percent, 37.5%. Boom. Got a crazy box there. There's your answer. All right, so hopefully these help. And that's it.